In this video, we're going to configure our VPC. So inside our VPC, we're going to have two public subnets that our images are going to run on, and we're going to have an isolated subnet for our Elasticache instances and our RDS instances. We will cover why I've decided to use a public subnet for this video. You could also make these private subnets. It really depends on your use case, and we'll cover that in just a sec. So one of the things I really actually love about CDK for using it to generate your infrastructure is the documentation for CDK is actually very nice for AWS services in general. So if we jump into the VPC documentation for CDK, when you go to the high-level constructs, there'll usually be an overview tab. An overview tab gives you a nice rundown of the AWS services in general, not just how to consume the API. So see here, gives a basic description of a VPC. It's a virtual private cloud, and it basically gives you your own virtual cloud within AWS to isolate all your resources from everyone else. So EC2 instances have to be launched inside a VPC, so it's generally a good starting point. So that's where we're going to start. Gives you an overview of the subnet type. So I said we're going to use public subnets for the application instances. So these are directly connected to the internet via an internet gateway. The reason I've decided to use public is because a lot of applications will require internet access. So if any part of your application needs to call out to the public internet, it'll either have to be on a public subnet or a private subnet that has a NAT gateway configured. So the most common one is a payment processor. So Stripe, PayPal, something like that. You have to call out to the public internet, consume a third-party API. Public subnets are the easiest way to do that. They're publicly accessible, both inbound and outbound. So don't worry about it being publicly accessible inbound. There are ways to restrict access still. Private subnets are not discoverable on the internet, so you can't directly route from the internet to them, but you can connect out to the internet via a NAT gateway. So you might be wondering, well, why use a public? You can use a private with a NAT gateway. NAT gateways are expensive. They're about $30 to $35 a month just for uptime, and then the data charges on them can get expensive pretty fast. So depending on your budget, private with NAT is a very viable option. But if you just need something cheap and the security profile is fine to restrict access to your public subnets, then just go with public. And then we have isolated, which basically don't route to the internet at all, and therefore there's no need for a NAT gateway because you can't get external internet connection from them anyway. I've also mentioned that we're going to create private links for SQS. We're also going to create private links for ECR and ECS. The service actually, the AWS ECS lives outside of here. And ECR actually uses S3 under the hood to store your Docker images. So we're going to create a private link for S3 as well. And one very expensive mistake that you can make when you do this for the first time is when you actually create a new VPC construct. So this is the most basic way to create a VPC. You just create a new VPC and you give it a name. So the default for CDK when it creates a VPC is to provision a NAT gateway for your VPC. So in the past, I have set up an ECS scheduled Fargate task that runs every 5 minutes. It was just a simple node script. So I was running node on Docker. Unfortunately, the node Docker image is about 600 megabytes. And one thing that is not obvious is, if we go back to our architecture diagram, every time ECS pulls an image from the ECR to provision onto one of these servers, it will actually, because they're not within the VPC, it'll actually go out to the public internet to grab this image and pull it down. So it'll actually go via S3, but essentially it'll reach out of your VPC via the public internet to pull the image into the cluster that it needs to run it on. So if you have a 600 megabyte image routing through the public internet and the default configuration is to create a NAT gateway, that means every time you need to pull an image down, you're going to be routing 600 megabytes through your NAT gateway. And NAT gateway charges on data usage. So if you have a scheduled task that runs every 5 minutes, pulling 600 megabytes of data just for the Docker image, I think I got slugged about $300 before I realized that's what it was doing. It was running for a few weeks, but still, it's an expensive mistake that you don't want to make. So the easiest way around that is to just provision your VPC without a NAT gateway. So you can override the defaults and say, I don't want a NAT gateway to be created in my VPC. And then all you need to do is just run all your ECS tasks inside a public subnet. And that's why I've decided to use this example for a public subnet. It basically means that this subnet has internet access. So when it calls out to the public internet to grab your Docker image, there's no data charges there. You're not going to get slugged a huge amount of money like you would going through a NAT gateway. But if you do want to run these in private subnets with a NAT gateway, there is a way to avoid that data charge. And that data charge is by using PrivateLinks. So PrivateLinks are basically what they sound like. They're private links between your VPC and Amazon services. So there's a really good blog post by AWS tutorial basically setting up PrivateLink for ECS. So they show you here the default construct. So your VPC will create a public and a private subnet with an internet gateway and a NAT gateway. Your public subnet instance will just go via the public internet gateway to grab your images, but anything inside a private subnet will go through the NAT gateway, which will go through your internet gateway to go grab these images. So as I said, that can get very pricey very quick depending on the size of your image. But the better way to do it is to basically use a private link, and your instance will go via the private link to grab things. And private links, essentially, because they don't need to reach out to the public internet, they're just reaching out within AWS data centers. It's actually a much simpler, much cheaper, more efficient thing. But it also gives you finer grained security controls. So we're still going to set these up, even though I said we're going to opt for public subnets. So technically you don't have to do this part if you don't want to. If you're happy running in a public subnet, you don't need to set up these private links except for SQS. But we're going to go through how to do it just for completeness. And that means in theory, we should be able to switch to a private subnet here. But again, if you want to just call out to a third-party service like a payment gateway, if you're using some kind of SaaS product to send emails or anything like that, you're either going to need a public subnet or a NAT gateway. So let's get started with some code. So here we have the code that we did in our last video where we just basically configured it to build and upload our Docker assets to the Elastic Container Registry. So under here, we're going to add all our code for the VPC. Now, the first thing we're going to need to do is actually install the CDK module. So if we go back to the CDK documentation, we can see here the library that we need. We can see here that the library that we need is this AWS CDK/EC2. So I'm just going to copy that. I'm going to jump back in. I'm going to change directory into my CDK directory. Now, if you're anything like me, you'll forget to do this a lot and you'll npm install into your root directory and you'll find all these issues. So if that ever happens, just think, was I in the right directory before I npm installed this? So we're just going to npm install it. That'll give us access to all the constructs we need. Now, what I'm going to do is copy across some code I prepared earlier. What I'm going to do is I'm going to set up my subnets first before I create my VPC construct. Basically, I'm setting up a subnet for our application, which is this public subnet here. I'm going to set up a subnet for our background tasks, which is going to be this one for the scheduler and the background jobs. And I'm going to set up, these are both going to be public subnets, but if you wanted to make them private, you would just do private. And the great thing about CDK is it's all in TypeScript, so you get great autocomplete. So if you, for some reason, didn't know the subnet types or you couldn't remember them, it'll autocomplete for you. But we're going to make this private, public, sorry, background public. And then we're going to have a third subnet, which is this one here, the isolated one for Redis and our database. It just takes a name and a subnet type. So there are subnets, very straightforward. Now we come to actually creating our VPC. So we just use this VPC construct. We give it a new one. We pass this in as the first parameter. We give it a name. I'm just going to call it my VPC. Now there are plenty of options that this construct takes. So if we have a look at the documentation and we go down to the VPC construct, you'll basically see here, these are all the constructor props. For our purpose in this video, we're going to explicitly set NAT gateways to 0 because I don't want to pay for one. And then we're going to pass in the subnet configuration. So if you just ignore these, it'll create a NAT gateway for you and it will create a public and a private subnet for you by default. but we're going to explicitly set these 3 subnets because we know that's what we want. We know we don't want a NAT gateway, so we're going to set it to 0. And this gateway endpoints, this is for the S3 private links, and they get defined within the VPC construct itself. So we have one for S3, and we've just, this is basically the API for it in CDK. And then we're going to go through and add our basically interface endpoints to interface with ECR, ECS, and SQS. So when you create a VPC, you get a whole heap of methods on that instance. One of them is add interface endpoint. First parameter here is just the name, and we're going to create one for ECR. We're going to create another one for ECR Docker, which the container registry needs to interface with Docker. It's covered in that tutorial. I can link it. We're going to create one for ECS. So again, ECS has a few different services that it needs to interface with. So we have the basic ECS one, we have the ECS agent and ECS telemetry. You can look up what they do in the CDK documentation if you're curious. And then we need to just create one for SQS, and that'll create the SQS private link. And that's all there is to it. That is literally all we need to do to set up our VPC with our 3 subnets, 2 publics and an isolated. We have a private link for SQS, ECR, ECS, S3. If everything worked, we should just be able to CDK synth this. This will let us know if there's any issues generating CloudFormation. And we can see that generated with no issues, so we should be fine just to CDK deploy, and that should all just work.